In Algebra 2, we talked about modeling real-world data with polynomial functions. We've already reviewed how to do linear regression equations in the graphing calculator and how to graph the scatter plot and the exact equation. Well, we're going to go back and we're going to do it again, except this time we're going to do it with polynomials. So when you graph a scatter plot, you're going to first have to determine which type of polynomial you probably are modeling. Now, the graphing calculator is limited to linear, quadratic, cubic, and quartic regressions. So it's going to be one of those. So we're not going to actually do anything higher than a fourth degree polynomial. If you look at this scatter plot, let's say that were the scatter plot in my calculator. The way we're going to determine which type of polynomial to write has to do with the number of times the direction of the graph changes. So the graph is going down, and then it changes direction and goes up, and then it changes direction and goes down, and then it changes direction and goes up. Since the scatter plot changes direction 3 times, we're going to use a quartic function. We're always going to use the polynomial that's 1 degree more than the number of times it changes direction. In this second one, it goes up, changes direction, down, changes direction, and then up, and then that's it. So it changes direction twice. So it changes direction 2 times, then we're going to use a cubic function because that's a polynomial of degree 3. A little review of how we put this information in our calculator. We're going to use the stat function. Oops. Stat is up towards the top of the calculator, and when you press stat, you end up with a, it says edit, so you want stat, and then you want to click number 1, edit, and then you should get a screen that has L1, L2, and L3. If for some reason it does not say L1, L2, L3, then press stat again, and then number 5, setup editor, and then hit enter so it says done. Sometimes people accidentally clear out the lists, or they do something else with the calculator. If you have information already in the lists, then what you're going to do is clear it out by putting the cursor on L1, pressing clear and down. Do the same thing with L2. If you already have information in L2, put the cursor on L2, press clear and down, and it'll be all gone. So in problem number 1, we want to model a polynomial function for it. The farther a planet is from the sun, the longer it takes to complete an orbit. We're going to make list 1 the distance in astronomical units from the sun, and L2 is going to be the period. It's the number of days that it takes for that planet to rotate around the sun. Remember, when you type the numbers into the calculator, go back and double check and make sure that you typed them all in correctly, because the number 1 reason you'll get the wrong answer is because maybe you transposed 2 numbers. The other thing you should check is that you have the same number of items in list 1 and list 2. If you accidentally have one more number in one of the 2 lists, when you go to write the equation, you're going to end up with an error message. Now, in this particular problem, I want you to notice that this is the planets in order, because we're the 3rd rock from the sun. Here's us. We're 1 astronomical unit away from the sun. It takes us 365 days to rotate around the sun. Now, Pluto's not a planet anymore, but it used to be when this book was written, which is why Pluto's still out here. So after you put your data in, let's do the review of how you do this. So you do stat, number 1, edit, and you put your information to L1 and L2. L1 is your input, L2 is your output. Then you quit and you go back to stat plot. So we're going to press second, y equals. We're only going to need to turn the stat plot on one time, and then it'll be on for the rest of our problems. So when you go to second y equals, you need to turn the first stat plot on, and it might be off. So if you press enter twice, it'll turn it on. If it's already on your calculator, well, then it's already on. After you've made sure that your stat plot is on, then you're going to go to Zoom 9, which I believe is Zoom Stat, which it is. And what that's going to do is it's going to restructure the screen of the calculator so that you can see the graph. So if you go to Zoom Stat, you should see the scatter plot on your graph. And this is the graph you see. So now let's determine which type of regression is probably going on. Well, it looks like the graph has no places where it changes direction. Therefore, it must be linear. So now we're going to go back and we're going to write a linear regression. In order to write the linear regression, we're going to go back to Stat. You're going to arrow 1 to the right to Calc. And then number 4 is LinReg. And depending on which type of calculator you have, some of you may get a whole list of things, and some of you, it just says LinReg at the top. So either press enter once or press it several times, and then the equation pops up. And the equation is y equals 2241.22x minus 4569.32. And that's the equation that represents the planets orbiting around the sun. If you know the astronomical unit, which is the input, and you want to find the number of days that it takes to go around the sun, which is our output y. Let's do it again here in number 2. The amount of food energy produced by farms increases as more energy is expended. The following table shows the amount of energy produced and the amount of energy expended to produce the food. We're going to put this in list 1 and this in list 2. So energy input will be X and energy output will be Y. So after I put the data in, and I double check the data, and then I go and do Zoom Stat to see what the graph looks like, I get this. There are no changes of direction again. So if there are no changes of direction, we're going to go with it being linear. And if it's linear, and I go write my linear regression equation, I should get y is equal to 0.04x plus 107.32. Let's go look at the next problem. The temperature of Earth's atmosphere varies with altitude. So I'm going to go put altitude into list 1 and the temperature in list 2. When I put it into the calculator and then I graph it, this is what I get. So in terms of how many times it changes direction, it starts up here and it goes, so it changes once, twice, and then it's kind of hard to tell. So what should we do? Is there a third change in direction? Hard to tell. So if you think there are 2 changes in direction and it's a cubic function, then the equation we're going to get is y equals negative 8.2, oh no, there's an, I'm going to be careful. There is scientific notation in this problem. It is negative point, let's see, 1, 2, 3, 4, 8, negative 0.0008 x to the third plus 0.099 x squared minus 3.57x plus 274.72. However, if you think at the bottom it's actually another change of direction and you think it's a quartic function, then the equation you're going to get is y equals let's see, I've got more scientific notation. 1, 2, 3, 4. So approximately 0.00005 x to the fourth minus 0.009 x to the third plus 0.568x minus 11.93. I feel like I missed something. That was an x squared. That's an x. And then plus 294.79. In the next problem, water quality varies with the season. This table shows the average hardness amount of dissolved minerals of water in the Missouri River measured at Kansas City, Missouri. So in list 1, we're going to put the month, and the month will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in list 2, we're going to put the hardness of the mineral. When you graph it, you get this. Now, this is again one where you can make it could be really like one of two choices as to what you determine the type of polynomial is. So maybe you think the graph does this, in which case you'll probably think it's a quartic function. However, you might think that this is just an accident, and maybe it looks like this, in which case it's quadratic. As long as you have a good reason behind it, I'll take either. So if it's quartic, then the equation is going to be y equals 0.053x to the fourth minus 1.56x to the third plus 1970x squared minus 110.03x plus 397.68. If you think, however, that it's quadratic, then the equation you're going to get is y equals 4.26x squared minus 53.11x plus 339.66. So when determining the type of polynomial from a scatter plot, we try to do it based on the number of turns we see in a graph. How many times does it change direction? Although sometimes determining how many times it changes direction can be a little iffy. So try to do the best you can. Like for this one, I probably would have picked the quartic one rather than the quadratic. And for this one, I probably would have picked the cubic function. Whereas the first two that we did were linear because there's no change in direction. And that is modeling real-world data with polynomial functions. If you have calculator difficulties, please let me know. Sorry, this is section 4.8.